This lesson is a continuation of 4.2 and 4.3, but this one is focusing on starting with scientific notation and converting it to standard form. So the steps are: determine the number of places you need to move the decimal point by looking at the exponent. Just like in the previous lesson, the exponent tells you how many times to move the decimal point. So you can see that right here, the exponent is 6, so that means we're going to move it 6 times. Here, the exponent is -4, so we're going to move it 4 times. The next step is to decide if you should move the decimal point to the right or to the left. So, remember that 10 to the 6 is a very large number. It's 10 times 10 times 10 times 10 times 10 times 10. So, if you have a positive exponent, 10 to the positive power, you're going to multiply by a number that's bigger than 1. So that means that this number here should get bigger since you're multiplying by a big number. You're going to move the decimal point to the left if the exponent is negative. You move it to the left because 10 to a negative number is a number between 0 and 1. From our lessons in topic 3, we know negative exponents mean fractions. So we're multiplying by a number that's between 0 and 1, which will make the result smaller. So we're going to move the decimal point to the left if the exponent is negative. Alright, so we are ready to write the answers. So for this first one, -5.8 times 10 to the 6th, the 6 tells us move it 6 times, and since it's positive, we're going to move it to the right. So we're going to take this decimal point, and we're going to move it to the right 6 times. 1, 2, 3, 4, 5, 6 times. Now, you can see all my loops, and I want to be very clear that your answers should not have loops in them. So make sure that you put your answer without any loops. My answer for this one is -5. I moved my decimal point so it's no longer there. I have an 8. And then look at all these empty loops here. All of these are empty loops, so I have to fill in each of those loops with zeros if they're empty. And then when I get to the bottom or back side of my loops, that's where the new decimal point goes. So I have 1, 2, 3, 4, 5 empty loops, so I have to fill in 5 zeros. And then my decimal point's at the end, and I don't really need to write it there. Now, a very common mistake is that people sometimes think that the exponent tells you how many zeros there are, and that is not true. The exponent tells you how many to move the decimal points, how many times to move the decimal point. Now, the last thing I'm going to ask you to do is go back to the problem, count from the back. Every 3 you're going to put a comma. And the reason we do that is so that it makes it easier to read. So this number is -5,800,000. Let's move on to the next example. This next example has a negative exponent, so we're going to move the decimal to the left 4 times. So we're going to take this decimal point that we see here, and we're going to move it to the left 4 times. So it looks like this. 1, 2, 3, 4. Now this time, I'm leading with a decimal point. So my answer is going to start with the decimal point. I have some empty loops in there. So I have 1, 2, 3 empty loops. So I have three zeros. And then I have the 1, the 3, and the 5. And notice that I did not write another decimal point. You can only have one decimal point in the problem. So that is the standard notation for that problem. Now we're going to do some examples, and the first few are exactly like the ones that we just did. Alright, so this first one, we're going to put our decimal point after the first non-zero digit. Then I have to find out how many times I move the decimal point. So I have 3.25. I don't have to write all the zeros that come at the end. I have to multiply by 10 to a power. The power that I multiply by is determined by how many times I move the decimal point. Remember, it's at the end if you don't see it. So I moved it 3, 6. I moved it 6 times, so my exponent has to be a 6. And then I have to decide if it should be a positive or a negative 6. So you look at the original problem. If the original problem is greater than 1, I have a positive exponent. So that's my answer. This next problem, I have to convert from scientific into standard. So that was on the last lesson. The exponent here tells me how many times I move it. It's a positive exponent, so that means it's a big number. Positive exponents mean 10 to the 4th is a big number, which means when we multiply, it's going to be really big. So I take my decimal point on the 4. I don't see one, so remember when you don't see a decimal point, it's always on the right-hand side. And I'm going to move that decimal point 4 places, and it needs to get bigger, so I'm going to move it 4 places to the right. So I'm going to have 4 empty loops. And I fill in those loops with zeros. And I have a decimal point at the end that I don't need to write. So over here in standard form, I have the 4, and then I have 0, 0, 0, 0. And I'm going to add in my comma. You always start at the back, and you move 3 times over to put a comma. So this answer is 40,000. Alright, the next one, I have 0.36. So I need the decimal point to go in between the 3 and the 6. So that first number is between 1 and 10. So it should be 3.6. That's the number between 1 and 10. We always multiply by a power of 10. And this time, my decimal point was here, and I had to move it 1 time. So my exponent has to have a 1 in it. Now, the last thing I need to think about is this number greater than 1 or between 0 and 1? So obviously this is between 0 and 1, which means my exponent has to be negative. So I go back over here and I put a negative exponent. So it's 3.6 times 10 to the negative 1. The next problem, I'm going to have a decimal point after the first non-zero number. So that means it's going to be 7.08. Now I needed that first 0 to be written there because that is a placeholder. But all these zeros, if I end in zeros, I don't need to write them after a decimal point. Then I'm going to multiply by 10 to a power. The exponent is how many times I move the decimal point. So let's count. I have a decimal point at the end here that I don't see. I move it 3, 6, 9, and then one more is 10. So I move it to 10 places. And the last thought process I have to do is this number, the original number, greater than 1 or less than 1. This one's greater than 1, so it's a positive exponent over here, and I am done with the problem. The next one, I have a negative exponent, so that means that this number here is going to be small because this is a very small number. So I have to make this number smaller. I move the decimal point 5 times because of that 5. And to make this number smaller, I have to move the decimal point to the left. So take this decimal, move it left 5 times. So over here in my answer column, I'm going to start with a decimal point. I have 1, 2, 3 zeros, 1, 4, 3 to finish off the problem. The last one, and we have 2 more that I'm going to do right now. So this next one, I'm going to put the decimal point after the first non-zero number, so that's after the 3, which means that's going to be a 3. We're going to multiply by 10 to a power. This number that I started with is less than 1, so that means my exponent has to be negative. And how many times I moved the decimal, let's count. So it's 1, 2, 3, 4, 5, 6, 7, 8 times. So that means that this value is 8 for my exponent. Alright, the last one, I have a positive 5. So that means that this number is very big. So I need to move the decimal point 5 times to make it bigger, and it goes this way to make it bigger. So we're going to move that decimal point 5 times. 1, 2, 3, 4, 5. I have some empty loops there. I fill them in with zeros. So my answer is 7, 2, 0, 1, and then I had 2 empty blanks, empty loops. So I have 2 zeros. And my decimal point is at the end there, so I don't need to write it. And then I'm going to put in my commas. So you start at the end. Every 3 numbers you put a comma. So there's a comma there. So that's 720,100. I'm going to start a new video for these last 3.